Hello students, welcome to chapter 10 vector algebra. Today I continue students exercise 10 question number 4. If A vector is equal to B plus C vector given, then modulus A is equal to magnitude B plus magnitude C is true? Yes, give your simple solutions for triangle rule. A to B I just made, second B to C, and third A to C. Is all three directions you very well known, and that's just all summations. The C opposite I will take C directions, A opposite to A directions, and B opposite to B directions. And you know that in a triangle sum of the two sides is always greater than third sides. So here students I mention in a triangle ABC, this AB directions is a C. Next, BC direction is a A and CA direction is a B. And all have to, you will take magnitude. Magnitude AB is a magnitude of C. Magnitude BC is a magnitude of A. And students, magnitude of CA is modulus of B. This is the sides. And students, magnitude of AB, it is nothing that it is a small c. Yes. Now, in a triangle ABC, sum of the two sides is always greater than third sides. I will take two sides B and C, rise. So this B and this C written. So in a triangle AB directions magnitude plus CA direction magnitude is always greater than BC magnitude directions. These are necessary, true for every triangle. So in a triangle ABC is always true. So what's your AB magnitude? Yes, AB magnitude is C. Here B and here A. It means your data is false. In your data here printed is equal to, but I will prove greater than. So therefore modulus A is equal to modulus B plus modulus C is false. Actually it is what? Greater than it will be correct. Now question 5. 5 also very easy. Yes. Find out x value if it is a unit vector. If x with I, j, k is unit vector, then find x. A simple unit vector means magnitude 1. So here students you will take in modulus 1 1 1. Is that one? Now take both separations. One of the modulus x and here 1 1 1. Now you know the very well modulus of the value 1 1 1. It is 1 square plus 1 square plus 1 square. It will be root 3. So what is modulus x? 1 by root 3. So x value plus or minus, yes, plus or minus 1 by root 3, and that's you create simple. Find out if x, then find the value of x. Yes students, now I continue next one. Question continue in the sixth one. 6 also very easy and simple way we will going that in the sixth one. Now students continue question number 6. Find a vector of magnitude 5 units and parallel to resultant of the vectors of the A given 2i 3j minus k and B I minus 2j plus k. First of all students, I define that resultant vectors means both plus. Yes. So resultant vectors, it means A plus B. Simple you added. What is your A? Twice I 3j minus k plus I minus 2j plus k. In short, it is 3i plus 1j plus 0k. You will write down 3 1 0 and that vector is called C vector. resultant vector. Now I want to parallel, it means I get necessary unit vector, and unit vector in magnitude taking 3 1 0 9 1 0 root 10. So what is the unit vector? Yes, R, I mean C cap C by modulus C in the same directions. Now see, I have known that 310 by root 10. Now I want to vector having magnitude 5 units and parallel to in these directions. So very easy, I just applied it into modulus and magnitude 5. So students, I taking magnitude 5 units and that I take easily answers. So after that, now a vector having magnitude 5 units means this one, and parallel to that resultant 5 units, and students continue parallel to C directions. It means this one. So this answer is a 5 times C cap. It is C cap, you know that 310 by root 10. You will take here simple conjugate. So students, here 15 5 0 root 10 I extra multiply and dividing, it will be 10. So 15 5 0 root 10 by 10. Just divide it. Yes, 15 by 10, 5 by 10, 0 by 10. So your answer is here students, 5 2 and 5 3 means 3 by 2 root 10 I plus here half root 10 j plus 0. Okay, and that's your students simple way. Your required vector is easily done in parallel to direction of resultant vector having magnitude 5 units. Now continue students, seventh one. Seventh also in the same way question asking, but there are three vectors given now. Yes, total three vectors. If vector A I j k, vector B twice I minus j 3k, and vector C I minus 2j plus k, again check I j k, twice A minus j plus 3k and I minus 2j plus k, find a vector parallel to, yes, a vector parallel to, yes, find a unit vector, sorry students, unit vector in parallel to twice A minus B plus 3c directions. Twice A minus B plus 3c. Very easy. First I define this value. You will take twice A minus B thrice C. Apply that. A I have 1 1 1 plus, sorry, minus. B I have 2 minus 1 3. Just only check numbers. And 3 C vector is a 1 minus 2 1. Now calculate. It's a 2 2 2 plus minus 2 1 minus 3, and here 3 minus 6 and 3. Now students, you total added 2 and 2 0, only 3. Here 2 and 1 3, 3 minus 6 minus 3, and last 2 minus 3 minus 1, minus 1 and 3, it is 2. Again 3 and 3 cutting, only 2 dead. And this vector is students 3i minus 3j plus 2k. But I want to unit vector. So students, that called you just R vector. And start. Now unit vector R upon modulus R. So you just students here define your modulus R. It will be known 3, 3 minus 2 that 9, 9, 4. Only square that 3 square, 3 square and 2 square 9, 9, 18 and 4, 22. And that you define students here answer R is a 3 minus 3 2 by root 22. So my answer is 3 by root 22 I minus 3 by root 22 j plus 2 by root 22 k. That's your answer. Is a unit vector parallel to in this directions 2a minus b plus 3c. And students, now after that we going to next question. In question number 8, that is a different questions now coming to related your divisions of the segment. Now students, new one, question 8. Show that the points A 1 minus 2 minus 8, B 5 0 minus 2 and C 11 3 7 are collinear. It means students, we will prove lies on the same line. And second asking, find ratio in which B divides AC. So first of all I start distance. First distance AB means magnitude of AB, directions. Now B position minus A positions. B I have 5 0 minus 2, A 1 minus 2 minus 8, and you will check your solutions. So 5 minus 1 4, here 2 and minus 2 plus 8, minus 2 plus 8 is 6. Students, here I just checking 2 common, so 2 1 3 and you will get your final 4 1 9, it is root 14. Definitely second also in terms of root 14 BC and AC also. So now students, I will start BC direction. C minus B. I have C 11 3 7 minus B I have 5 0 minus 2. So that you just subtracted. 11 minus 5 6 3 and 9. Just you take 3 common. So remaining here 3 2s are, 3 1s are and 3 3s are. Definitely it is also root 14. That's your second part. AB 2 root 14, BC 3 root 14. Now I will take to third, AC students. So AC distance, direction of AC derive. And easily you will cover your answer. So your third part. Now AC, so distance in AC in direction of AC, C minus A. Your C is 11, 3, 7 and A I have 1 minus 2 minus 8. So my answer is 10. 3 plus 2 5 and 7 plus 8 15. I think 5 common taking. So your 5 2s are, 1s are and 3s are. It is root 14. Check this AC distance 5 root 14. Sum of the both 3 root 14 and 2 root 14. So I will write down, therefore AB distance plus BC distance is equal to AC distance. Means it is confirmed collinear, not made triangle. Yes. So AB is what? 2 root 14. Here 3 root 14 is equal to 5 root 14. That's why we will draw the drawing. AC is the longest length, B is the internal, and confirm A, B, C are what? Collinear. Therefore, we can say A dash, B dash, C are collinear. Now secondly asking, find ratio in which B divides AC. So very easy. Therefore ratio of point B divides AC from A side. Means this ratio students, AB by BC. And AB you already known. How much AB? 2 root 14. And BC also known students, 3 root 14. Answer is 2 ratio 3. I mean 2 divided by 3, and that students easily and happily question number 8 is also students here done. Now I go to continue our question number 9. Students, in question number 9, that also one of the ratio wise question asking, and in the midpoint wise the question is given. Question number 9 that. Now continue students, question number 9. Find the position vector of a R which divides the line segment joining the points P and Q, where vectors P given 2a plus b and vector Q given a minus 3b. Divide externally. Yes, these are main points. Underline that first. Externally in the ratio 1:2. Students, generally internally ratio are positive and externally ratio negative. So I will use here -1:2. Then after prove, show that P is a midpoint of line segment RQ. That's the second proving. First of all, I going to that the external divisions for the P and Q having both positions given 2a plus b and Q I have a minus 3b. And here point is R. The divide parts, the ratio in the form of 1:2, but external division -1:2. So here position vector of R, just here you consider it is m/n, and this position vector is considered small q P, and that is your small q. Just only understanding. So position vector of R is m with the q positions plus n with the p positions by m plus n. Now I have m -1, q position is a minus 3b plus 2, p is twice a positions plus b by -1 plus 2. Students, first of all put in q positions vector minus p position vectors. Now apply the solutions. So here answer is -a plus 3b 4a plus 2b upon 1, and you will create easily position vector of R. It will be 3a plus 5b. Yes students, 3a plus 5b upon 1, 3 and 5b. That's your position vector of R done. Now secondly prove it is midpoint of P of RQ segment. That's my second proving. So very easy. Here are utilizations position vector of R also. Now we find position vector of midpoint of segment RQ. So students, you can plot first R to Q. R known, that's one, 3a plus 5b, and students Q also known, a minus 3b, and you will check here midpoint. Yes, you know that ratio 1:1, mn value apply 1:1. So students, position vector of midpoint, very easy, both positions plus by 2. These are R, that's the Q position by 2 because mn 1:1, and students R Q vector is 3a plus 5b, and here a minus 3b upon 2. Now very easily you get answer 3a plus a, it will be 4a, here 2b, and check it is same as position vector of P. What's your P? 2a plus b. Yes, definitely it is 2a plus b by 2, and that's answer is 2a plus b. Students, I will mention it is position vector of P. It means confirm our proofing is done Yes, P is the midpoint of RQ. So that's why I written last. So P is midpoint of students RQ solutions, and that's very easily students here done. Now I go to continue our question number 10. That also in similar types questions. Indirectly students, here all topics are revised in one by one steps. Now students, time coming to IMP questions. You tick mark in IMP list. Question number 10. The two adjacent sides of a parallelogram are respectively given to I say minus 4j plus 5k and I minus 2j minus 3k. Find unit vector parallel to its diagonal and find its area. Students, first I derive area. After that I explain unit vector parallel to diagonals. That's your one of the parallelogram. Consider A to B directions, B to C directions, C to D directions and D to A directions. And that's A already written here. Sorry, by mistakes. Here A and here B. There are two directions. Adjacent sides given. So students, here given two adjacent sides AB directions, that is called A, which have 2, minus 4, 5, that one. And secondly I take BC, that is called B, that is 1, minus 2, minus 3, 1, minus 2, minus 3. And now how can they define area? Easy, magnitude of A cross B. So I first take A cross B. Yes, after that I take magnitude. So A cross B students, 2, minus 4, 5, 1, minus 2, minus 3, and apply in the best way I, J, K. Here 2, minus 4, 5, and secondly 1, minus 2, minus 3. And doing simple way, I, J, K forming, that will be I minus J and plus K. And simplify, determine its value. 4 3 is a 12 plus 5 2 is a 10. Second minus 6 minus 5 and last minus 4 plus 4, it will be 22I plus 11J 0K. It means 22 11 0. And now you will take common 11 and take it magnitude value students. Easily you will define that. So area of parallelogram, magnitude of A cross B. That's why I will take magnitude. So therefore modulus of A cross B students, it will be modulus 22 11 0. 11 common taking 2 1 0. 11 2 is 22 and that is under root 4 1 0. 11 root 5 and that is your first answer done. But now second, diagonals. Unit vector derive parallel to its diagonal. So students, AB BC, AB to BC. Now I will take that directions, A to C. Actually A to B, B to C. It's a diagonal plus. It means now required vector, have parallel to, yes, parallel to its diagonal. Students, I will take diagonal parallel to, it's nothing, A to B plus B to C. I mean A plus B. And A, you know that 2 minus 4 5 1 minus 2 minus 3 and calculate the answer. Here 3 minus 6 and 2, and that's you create, you will take now C vector. Yes, and that is your diagonals vector, define that AC. Now I want to parallel to its diagonal and also unit vector. So students, you will take now here magnitude of C. It's that modulus of 3 minus 6 2. So 9 36, 4, 49. It will be 7. So required unit vector parallel to, yes, unit vector our parallel to its diagonal, that will be C cap, C by modulus C. Yes, that's your students answer. And what's your C? Yes, C by modulus of C, and your C vector is 3 minus 6, 2 by 7, and I will take now in I-K. So students, 3 by 7I, 6 by 7J plus 2 by 7K, that answer is your easily way to unit vector parallel to its diagonal wise. Students, easily and happily here done. Now continue students, question number 11. Eleventh is a very easy and short numerical students, and easily I explain here. Now students, question number 11, this is also IMP questions. Show that direction cosines of a vector equally inclined to the axis with OX, OY and OZ are 1 by root 3, 1 by root 3, 1 by root 3. Students, are equally inclined means angle alpha, beta and gamma are same as in the direction of that OX, OY and OZ. So students, here I will take here angle alpha is making equal angle with x-axis, comma y-axis and comma z-axis, either OX, OY and OZ. So students, generally known formula cos square alpha plus cos square beta plus cos square gamma is equal to 1 direction cosines. But here alpha, beta, gamma are same, where alpha, beta and gamma are equal. That's why we will take cos square alpha plus here also alpha and here also alpha, and you create your solutions is that 3 times cos square alpha. So what's your cos square alpha? 1 by 3 means cos alpha 1 by root 3. It means cos beta is also 1 by root 3 and cos gamma is also 1 by root 3. So students, your direction cosine is done cos alpha comma either cos beta comma cos gamma, but I will write down cos alpha because alpha, beta and gamma same angle, and that's your answer 1 by root 3 comma 1 by root 3 comma 1 by root 3, and that's your students easily and happily here this proofing is done. And students, now here question number 11 ending, I stop this part and further explanation students as well as I explain in next part. Bye bye.